Okay, happy Saturday to you, Math 092 wonderful Essex County College student. So, chapter 10, module 10, dealing with polynomials is a nice slow way to ease you into factoring. Factoring is our next big thing in Math 092. So, like I said, most students have trouble. Our first big thing was equations. The second one was graphing and now factoring. So it eases you in by getting you comfortable with working with polynomials. Polynomials, right? And it first started out with the first basic operation of the four, which is addition and subtraction, which I promise you already know how to do. So from your text on page 130, it introduces you to adding polynomials. And basically what that is adding expressions, right? And we know that they're called expressions because I hope you said it, because there is no equal sign. And yeah, because there's no equal sign. So you're not going to be solving anything. We're just going to be doing what with expressions? We are going to be simplifying them. In this case, they're going to say add, which is a form of simplifying. So on page 130, I'm just working the example so that you can have space to work out the problems, the exercises in the book, which is very few, as we know. So I'm being conservative. So basically, you already know how to add and subtract polynomials. Don't let the parentheses confuse you. Basically, yes, if you look at this technically, this expression only has two terms, because we know that when we parenthesize a group of terms, we turn them into factors. So this is one factor plus another factor, give us two terms. So what you want to do here, you want to assess, is there anything I can simplify within each parentheses? Hence using the rule of order of operation. And when we look at it, nope. So you can actually rewrite this expression without the parentheses. Now, the reason why it's also in parentheses is that the text want to introduce you to adding these polynomials or this expression two ways. The first way is called, I don't know if the book had a first and second way, but it's called a horizontal format. It's two format, horizontal format, which means you combine the like terms, because that's what you do when you add and subtract polynomials. That's why I said you already know how to do it. It's combining like terms, simplifying expressions through combining like terms. And the reason we're not evaluating it is, yep, you guessed it, we have no values for these variables to plug in. So the horizontal format are also known as side by side. I don't know if the book says that, but I know I said that. It's side by side, where I'm going to put the like terms next to each other, right? So here we go. We have a 3x cubed term plus a 5x cubed term minus a 5x squared term. Take the sign with each term, plus a 4x squared term. Here we have a constant by itself and a 3x term by itself. They do not have any like terms to match or put side by side. But I'll just keep it in descending order, meaning I start from the highest power and I go down. So I'll do 3x plus the constant 2, which in actuality is really saying, so this is x3, x2, x1, and this is actually x0, because anything to the 0 power is 1, and 2 times 1 is 2. All right, a little in-depthness for you. Now, so here we are, we have the like terms next to each other, and this is called the horizontal format. Now, with the horizontal format, we perform our operation as we know how. And when we're combining like terms through simplifying our expression, we know we add the coefficients of the term and we keep the variable and exponent as is. So in this case, we have a positive 3 and a positive 5. So we have like signs, we add and keep the sign as a positive 8x cubed. Here we have a negative 5 and a positive 4. On like terms, we subtract, keep the sign of the greater magnitude. So there's actually actually 1x², or because we're so advanced in our game by now, it's just x². And then we have plus 3x. There's nothing to combine or simplify with, and we have 2. And this is our solution to our expression where we are asked to add the polynomials, right? And same as saying simplify this algebraic expression. Now, the other format is called the vertical format. And yes, you guessed it right. Vertical format means now we're going to line them up underneath each other. So I'm going to say under each other, right? So the horizontal format is side by side. The vertical format is under each other. So that's basically why they put these in groups of parentheses. No multiplication is happening here because there's no factors outside this parentheses to apply the distributive property. That's why you can drop the parentheses and continue. But like I said, the parentheses is placed there to determine if you want to attack this problem in a horizontal format or vertical format. So here we go. I'm going to rewrite the expression. Here we go. And now I'm going to line them up underneath each other. Vertical format. So here I'm going to place the 5x cubed under the 3x cubed, my 4x under the 4x term, and just for the sake of not making, and this is why I don't like the vertical format, because when you don't have things to line up, it's like it gets confusing. But I'm going to leave a space here, and I'm just going to put plus 3x over here. You see what I did? And now I'm going to combine my like terms by adding the coefficient. So that's 8x cubed minus x squared plus, there's nothing here. You know what? I could use 0 as a placeholder. Placeholder. All right. So that is just 2 plus 0 is 2 plus 3x. Now, this is not in order of hierarchy. It doesn't matter. This answer is fine. But to look like the best mathematicians they are out there, we can put it in order. Just to make your work look neat, we can put it in order of hierarchy. Either way, on an exam, I will take either solution. Also, I'm not sure if the exam is going to specify what you should do in horizontal format or vertical format. Most likely, they'll ask you to choose between, but whichever works for you is fine, as long as you are able to add this polynomial and work it out correctly. All right, let's move on to subtraction.